Alright class, welcome to another day of notes. We have a couple sections to get through today over tangents and secants, all to do with circles. So here we have our warm-up, number one here. Goes back to a couple different theorems we looked at so far this unit. The first one being that the angle A there, the 3x plus 9, is going to be equal to 1/2 of the arc CD. So we're going to double that to make it equal to CD. So we're going to do 2 times 3x plus 9. And that 8x minus 1 is a central angle. Central angles are congruent to the arcs, so that means we can set this equal to 8x minus 4. So now we have our equation to solve for x. Once we have x, that's all we need to do. It says to find x. So 2 times 3 is 6x, plus 2 times 9 is 18, equal to 8x minus 4. When we subtract 6x from both sides, I do this like this so we don't end up with any negatives. So we have 18 equal to 8x minus 6x is 2x minus 4. We add 4 to both sides. So we end up with 18 plus 4 is 22, and 22 is equal to 2x. We divide by 2 on both sides, and x is equal to 11. There's our final answer. Doesn't say any units, and really it's part of each of these things, so no unit would be needed. Number 2, the measure of an arc is 95 degrees. What is the measure of an inscribed angle that intercepts it? So that means that this goes back to one theorem, and this is basically what we did on the first one for the angle A. But in reverse, we know the arc, now we're going to get the angle, so that means we just need to take our 95 and divide it by 2. So 95 divided by 2 comes out to be 47.5 degrees. Alright, so we got a few vocab words today. I think it's 4. Tangent, point of tangency. So a tangent is a line that crosses or that touches a circle in one point, and that point is the point of tangency. Common tangent means that they have two circles near each other that have the same tangent, and a secant is basically a chord, but a chord doesn't continue outside of the circle. A secant will continue outside of the circle. It's a line instead of a segment. So here we have two circles. You need to copy the figure, and all we need to do now is figure out if it has any common tangents between the two circles. If not, then we just need to state that it has no common tangents. And since we have a circle inside of another circle, two concentric circles, that means there is no tangent. So no common tangent. There's no line we can draw that will touch on each of those circles just in one point. And I mean line, no segments. Obviously we can draw a little segment that just goes into each of these circles and touches them, or goes through them, but doesn't just touch the circles. So here is another example. Again, copy the figure, same process. So here we definitely have some common tangents, and you can see that they go across the top of this, right? Oh, the line's not good. Let's see if I can get a good line here that will actually do what I want it to, and there we go. You can see that that line touches both of these circles, right? We'll also have one from the bottom, right? And these will intersect at some point, but my drawing isn't perfect. You can see that there are two lines of tangency. We don't have any more than that. So there they are, drawn better than I can do. So all I would just say is we have two common tangents. All right. On to our next problem. Our theorem first. In a plane, a line is tangent to a circle if and only if it is perpendicular to the radius drawn to the point of tangency. So here we have our tangent line down the bottom, L, and it touches the circle S at point T, and ST is perpendicular to it, and it's a radius. So we're going to use that now. And this example, because we know that in order to be a line of tangency, or a tangent line, at the point of tangency, they have to be a perpendicular intersection. So what that means is this triangle here needs to be a right triangle. If it's not a right triangle, then it's not a line of, or a tangent line. So what we're going to use is Pythagorean theorem. So we're going to see the 20 squared plus the 21 squared, the two legs, needs to be equal to 29 squared. We're not going to put any equal sign though, because we're not sure if they are equal or not. So 20 squared is 400. 21 squared is 441. And 29 squared is 841. We add 400 and 441, we get 841, which is equal to 841. So that checks. So yes, LM is a tangent line. All right. Give you a couple seconds. Go pause it if you need to. Here's our next one. Same concept, but now we're looking for x, and we don't have our radius. So if we had the radius in one of those spots, it'd make it really easy to find it in the other spot. So x is our radius, so we're going to say that x squared, this does say it is tangent, so that means we can say it's equal in our Pythagorean theorem. So x squared plus 24 squared, our two legs, is equal to x plus 16 squared. X plus 16 is the hypotenuse. So we have x squared plus 24 squared is 576. And x squared plus 16 squared we need to FOIL, or you can set up, if you need to, two of them. But this is a binomial squared, and because of that, all you're going to do is square the first one, square the last one, multiply them together, or the two terms together, and multiply by 2. That's the cheat here, right? So x squared plus 576. So our first term squared, the 2 multiplied together would be 16 times x, so 16x times 2 is 32x, and then 16 squared is 256. Now we have a positive x squared on both sides, and because they are both positive, they are going to eliminate. If one was negative, they would double. So we end up with 576 equal to 32x plus 256. We can subtract 256 from both sides. 32x on the right, and 576 minus 256 comes out to be 320. And we divide by 32, and x comes out to be 10. And that's all we needed. Alright, next problem. New theorem. If two segments from the same exterior point are tangent to a circle, then they are congruent. So what that means is we have this point B all the way out to the right. B has two lines going out to A and C, and at point A and point C, those two lines are tangent. So that means that AB and CB are congruent. So our first problem with this, basically, just like everything else we've done so far really this year, if you know these theorems, then you'll know. Sorry about that, got an email. Didn't realize my laptop wasn't not muted. Sorry, you have to witness all that. So what we're going to do is set these two equal to each other because C is a common point. We know that they are both AC and BC are tangents to circle C, or circle Z, sorry. So that means that we just need to find x, and 4x minus 3 is going to be equal to 3x plus 2. So 4x minus 3 equal to 3x plus 2. Subtract 3x from both sides. So x minus 3 is equal to 2. And we just add 3 to both sides. So x is equal to 5. And that's all we're looking for. So our next example is using the same formulas. However, this is a bit more detailed, right? And it's kind of hard to tell, but I verified this before I figured out how to do this problem or did the work myself. That 2 centimeter at the very top is how long QN is. And based on the theorem that we just learned, QN and QL are going to be the same because of those lines being tangent. So, lots of things congruent here. We got that QN is going to be congruent to line QL, and they're both 2 centimeters. We know that RL is congruent to RM, and because of that, RL is the other portion of the QR line, right? So if we subtract 2 from 8, that's how long this line is. So it's 6 centimeters. I'll draw that on here for you. Oh, sorry. Hold on. Drew that in the wrong spot. So that's our 2 centimeter. This thing is 6 centimeter. Okay? And then our last two sides, or two portions of this, we have the SM is congruent to SN, which is 10 centimeters. Okay, so now we have all these bits of this. We have 2 of each of these, okay? So you can do this a couple different ways. You can multiply all these by 2, add them together, or we can say we know that the sides of the overall triangle are 6 plus 10, 6 plus 2, and 2 plus 10. So that's 16 plus 8 plus 12. We got to add those together. We get 36 centimeters for the perimeter. Next problem, or next theorem, sorry. This one we're getting into secants now. And it says, if 2 secants or chords intersect the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. So, you can see the formula there below. There's a combination of below and beneath. Beneath the words, we have that measure of angle 1 is equal to 1/2 of the measure of arc AB plus the measure of arc CD. So, same applies for measure of angle 2 and the arcs with it. Alright? So you can always pause it and check and make sure you know what this is saying, by the way. So here we have 88 as our FG arc, EH is 76. We're trying to find X, the angle inside. So because we're trying to find the interior angle, or the angle inside that they intersect at, that's going to be 1/2 of the 88 plus the arc that its vertical angle intersects. That's the 76. So we add all these together and multiply by 1/2. So 88 plus 76 comes out to be 164. Multiply by 1/2 or divide by 2, and we get 82 degrees. All right? So we got two more examples of this exact theorem still. So we'll keep going. So here's our next one. Same idea. However, we don't know the arcs that are actually intercepted by the point, or by that intersection, or the angle we're trying to find, sorry. So what we are going to do is find the other angle first, and then that other angle should be supplementary with x. I'm going to call that angle y, so I'm going to write that in here. So angle y, same process we just did, is equal to 1/2 of the 62 plus the 96. 62 plus 96 is 158. And then when we multiply by 1/2 or divide by 2, we get that y is 79. So now we're going to take that 79, and we know that x is equal to 180 minus 79, or y. So when we actually do that subtraction, we get that x is 101 degrees. All right? Next one, we got one more just like they're using the same theorem. A little bit different though. Now, our x is one of the arcs, so we're going to work backwards. So, we know that our angle inside is 60, equal to 1/2 times x plus the other angle, or the other arc, which is 25. So, first thing we're going to do is multiply by 2 on both sides. It's going to cancel the 1/2, and 2 times 60 is 120. The x plus 25. We're going to subtract 25 from both sides. So our x comes out to be 95 degrees. And there's our answer. Alright, so now we have a new theorem to look at. If a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So, what that means is a very similar formula of what we just had, or what we've looked at previously, really. The measure of angle 1 is equal to 1/2 of the measure of arc AB. And same for angle 2. The measure of angle 2 is equal to 1/2 the measure of arc ACB. This is similar to the one we looked at, we had to deal with in the warm-up, with central angles and the measure of the arc that goes with them. Or not central angles, sorry. For inscribed angles and the measure of the arc that they intersect. Okay, so here we have to find the measure of angle QPS. So let me mark what that angle is. QPS is that angle right here. So we're looking for the angle that goes along with the arc that we're given. So that means all we have to do, the measure of angle QPS is equal to 1/2 the measure of the arc, which is 250. So 1/2 of 250 is 125. That's it. So, let's do another one with this theorem. So again, we are looking for the measure of arc BCD now. That's this arc right here, which is on the other side from the angle that we have. So there's a couple options you can do. You could subtract the 108 from 180, double what you get, and that's your answer. Or you can double what we have now, and then subtract that from 360. Either way works. Let me show you both. So we have, the way I said first, we would do 180 minus 108, which gets us 72 degrees. So that is the other angle, and we just need to double that to get our arc. So 72 times 2 is 144. Now, we should get the same answer if we go the other way. So if we take what we do have, the 108, and we double that, we should get 216. And we take the 216 and subtract that from 360. And it definitely comes out to be 144. So we got the same thing twice. 2 means true, as my college professor used to say. Probably still does, actually. If two secants, a secant and a tangent, or two tangents intersect the exterior of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. So all 3 of these images use the same formula. This one is similar to what we did previously, however now instead of addition, we're subtracting. So same concept, different equations. So let's use these formulas. We'll use this a couple times and then we'll have our exit ticket. So here we have our angle on the exterior, the 62. Using this formula is going to be equal to 1/2 the difference between the two arcs inside. So the big one, the larger one, the furthest one away from the angle, it's always going to be larger. So that's going to be the first one that you subtract away. Otherwise you'll end up with a negative that you don't want to deal with. Doesn't make sense to get anything negative here. And then what we're looking for, I'll label as X. That's arc BC. So first thing we're going to do here, multiply by 2 on both sides. Gets rid of the 1/2. 62 times 2 is 184. Equal to 141 minus X. 184. Sorry about that. Having a brain fart. That's 124. Okay, I need to go home. It's the end of the day. That makes more sense. That's what I have in my notes too. So we subtract 141 from both sides. Then we get that a negative X is equal to negative 17. So that means that X is equal to 17. Alright, so let's see our last example problem here. Same theorem we're going to use. Oh, actually, this isn't our last. We have 2 more. Sorry. I missed that one in my notes here. So this one here, same exact theorem. Now we're looking for the larger of the 2 arcs, though. So we have that 40 degrees, the angle. So we equal to 1/2 of the one we're looking for minus the 140. Again, multiply by 2 on both sides. 2 times 40 is 80, equal to X minus 140. And we add 140 to both sides. Much easier when you're trying to find the larger one. No negatives end up coming around. And 80 plus 140 gets you 220. Alright, so now we have one more. Here's our last example. This one's a physics example, near and dear to my heart. The diagram shows the path of a light ray as it hits a cut diamond. The ray is bent or refracted at points A, B, and C. If the measure of arc AC is 96 degrees, the measure of angle S is 35 degrees, what is the measure of angle RBT? So, we're going to use the exact same formula. So we know that angle S is 35, that's our angle. Our smaller arc is what we're trying to find, or our larger arc is what we do have. So this one's going to have the negatives floating around. So our larger arc AC is 96, and we're going to subtract away the one we're looking for. So multiply by 2 on both sides. 35 times 2 is 70. equal to 96 minus x. We subtract 96 from both sides. And negative x is equal to negative 26. So that means that x is equal to 26 degrees. All right, your exit ticket is pretty much exactly this problem, just different numbers, all right? I think you can handle it. Here you go. Oh, sorry, forgot about this a little bit. If you want to take a picture of this, pause it, take a picture. These are all three of the things we looked at just now, just on the second half of the notes. And those will help you out a lot. Here's your exit ticket, just like the one we just finished. And we will see you next time.